Hello, students. We are in 8.3. I had another student mention, hey, I've got a couple questions on number 12 and number 15. And so if I look here, 12 and 15 in 8.3, I did not do those. So good. Let me hit those and see if we can get you on the right track. 12 and 15. So 12 relates to this function composition is what we call it. That's when we have two function boxes right next to each other. And I hope at this point you feel pretty comfortable with the idea that you put something in here, you get something out. It says f of x, which is x minus 1. So if somebody put a 5 up here, you got a 4. And then think, what do you do with that 4? You drop it into the next one. This function multiplies it by 7. So at the end of the day down here, my final result will be 7 times x minus 1. If 5 went in on top, the 4 comes out in the middle. 4 times 7 would have been 28. So that gives me an idea of how these functions work together. However, question 12 says something a little bit different. Now let's read it carefully and see if we can't kind of pick up on what they're laying down. All right, so what does it say? It says find all inputs. I'm trying to find the inputs. Okay, that's the stuff way up here at the top, for which the final output, okay, let's pause for a second. The final output, not the intermediate output, the final output. So the final output we know is 7 parentheses x minus 1. That's the final output. And it says it has to equal twice the input. So all I'm doing is writing exactly what they said. I'm just putting in the component from this particular problem. Okay. So there you go. There it is. Your goal now is to say, what can I do? Your goal now is to distribute, perhaps, get all of the x's on one side. Okay. That's your goal. Okay. Again, your goal at the end of the day, you'll have like an x equals. X is the input. And you may find that there's only one solution. You may find there's multiple solutions based on the equations you have, but that's the goal. And then you can go back and check it. Whatever you find, you go back and put it in at the very top and work your way back down, work your way down. Let's just say that you came up with the answer of, I don't know, 15. Making a number up here. 15, got it. What is 15 minus 1? Well, that's 14. 14 times 7 would get me 98. And you'd say, oh, okay, is this equal to twice the input? And I'd be like, no, no, it does not equal twice the input. So yeah, I think we're about done. That is a failure. If you came up with the number 15 and you check it and it doesn't work, go back and see. Did you make a mistake somewhere in the middle? All right. So that is it for question 12. Let's take a look at 15. 15. Okay, so consider this function. Find all possible inputs for the following outputs. All right. That one looks a little bit intimidating, maybe. Maybe that's part of this, is because they've now given you a question that has like a fractional function. But let's just pause for a second and let's do something with this. Now it's asking us to do something different, but I want to say, what would I do if somebody said find f of 5, right? We got to have this down. So here's my function. F of 5. Well, wherever you see an x, you're going to put a 5. So it's going to be 2 times 5 for you, minus 1, and 2 times 5 on the bottom, plus 1. 2 times 5 is 10, so 10 plus 1 is 9. 10 minus 1 is 9, 10 plus 1 is 11, and that would be your answer for this one. That'd be the output. So if you were graphing that, it would be this point. This would be my x coordinate first and my y coordinate second. Now it does say find all possible inputs that will get you to an output of 2 or get you to an output of 0. Okay, so all they're doing now, what you have to understand is they're just giving you the output at the end. Well, you know the output has to look like this. It has to look like 2x minus 1 and 2x plus 1. And you could say, okay, when does that equal the number 2? Okay. If you prefer, yes, you could write this as a 2 over 1. And if you do write it as a 2 over 1, you could then use your properties of ratios and proportions back from chapter 6. If you weren't in the class before, this is section 6.4, ratios and proportions. You could also not worry about that and just say, let me just get rid of my fractions. Maybe that's what's kind of screwing me up. So multiply both sides by 2x plus 1. And if you do multiply that quantity on both sides, right, they will eliminate because of FLOF, and you'll end up with 2x minus 1 equals, and then now just distribute, and you'd say 4x plus 2. And now take a minute, but can't use magic boxes here yet because I got x's on both sides. But if I take 2x away from both sides, now I could say I have -1 equals 2x plus 2. And if you want to use magic boxes here, you can. If you want to go back and do something more algebraic, subtract 2 from both sides and then divide by 2. But if you wanted to use magic boxes, you would say, okay, I'm going to start with x. And then the first thing I would do is I'd multiply by 2 because that's what it says. And that gives me a new box. And then I would add 2. Okay, there we go. And that would give me my final box. My final box is -1 because that's what it told me I got over here. And if I was going backwards, I would make sure if I was adding to go to the towards the right, I would subtract to go to the left. If I was multiplying here, I would divide. So if I go backwards, I can actually just follow this along and say, okay, -1, but take away 2. Got it, -3. Now I have to divide by 2. So I get -3 halves. And that would be my input to get me an output of the number 2. Okay. Now, as with everything, you can go back and check it. So let's go back up here and let's check it. Okay. So this says f, oops, wrong one, f of -3 halves. Okay, let's see here. It's going to be 2 times -3 halves minus 1 over 2 times -3 halves plus 1. Okay. And let me get just a little bit more white space. That'll give me room to work. Okay, so let's see here. So 2 times -3 halves would be -3. So I end up with -3 minus 1. And then 2 times -3 halves is -3 plus 1. Let's see what we get. -3 minus 1 is -4. -3 plus 1 is -2. And -4 divided by -2 is the number 2, which is exactly what we wanted. Big happy face there because it worked out for us. So I kind of pushed through that first one. I'll expect you to do B, C, and D. Very similar. Nothing really changing conceptually. Just maybe the numbers are a little bit different in value. All right. Let me double check and make sure that I answered all the questions from that email, number 12 and number 15, both of those from 8.3. So that should do it. All right. Off you go.